Hello my dear students, once again most welcome back in my YouTube channels. Today we have to learn about the capacitor and capacitance. This is the most important chapter, most important topics for you. Okay, I have covered some topics in chapter number 2, right? Those students missed that one, please go through in my YouTube channel and just type that topics by Devi Dayal Nagwar. Easily you will get all that videos, right? Let's see about the capacitor and capacitance. These are two different things, capacitor and capacitance. Capacitor, that means it is a one type of device, right? Capacitor is a one type of device which it can be stored the energy in the form of electric field and electromagnetic wave, right? Suppose we have to take two conductor, right? Suppose this is the conductor, here is the plus q charges, right? And here is another conductor, this is minus q charge, right? That means here we have to residing the charges here, okay? Then it's changing in potential difference and electric field, right? We have to increase the charges, then it will be increase the potential difference, potential and its electric field. How? Because our relationship between the electric field and charges, our formula was there, right? Our electric field is equal to our K Q divided by R square. That means giving the relationship this one, okay, is directly. That's it. We have to increase the charges in any conductor, then it will be increase the electric field. And same as potential V is equal to KQ divided by R, this one, right? That means same process over here, we have to increase the charges in any conductor, right? Then it will be increase the potential also, right? It is capacitor, it is a device which has to take two conductor with finite distance, right? Then between these two conductor stored some energy in the form of electric field, okay? That is the capacitor. I have already written over here. It is a device which can be stored energy in the form of electric field and electromagnetic wave, right? Potential of this one, suppose V plus and this is V minus. Potential difference between these two, that is the zero, because this is plus minus, it will be zero, potential difference, right? Here giving the relationship between these two conductor, that means giving the relationship between the charge and potential and field. It is, we have to increase the charge, then it will be increase the potential. That means this is Q is equal to, we have to remove this one, CP. This C is the constant of proportionality, that is called the capacity of this capacitor. That means from this one, C is equal to our Q by V, okay? This C, where C is constant of proportionality, is known as capacitance, capacitor. Yes, capacitance, it's SI unit of C is our, according to this formula, okay, Q, that means coulomb per volt, okay. This one for its name is farad. Farad, it is denoted by F. That means we have to got about the capacitor and capacitance, right? Capacitor, it is a device, right? Energy in the form of electric field, okay? And capacity, that means it is constant of proportionality between this one. It is not depend on the voltage, not depend on the voltage charges. Capacity is not dependent on the voltage and charges. It is depend on the geometrical figures, a configuration of the conductor, right? That means it is depend on the shape, okay? Capacity is depending on the its shape, size and distance, right? This one, and nature of the medium, okay? Its medium. Capacity, it is depend on the geometrical configuration of the shape of the conductor, that and this side shape, okay? Then our this one medium, right? Doesn't depend on this capacity, potential and charges and electric field, this one, okay? Next topic, that means derive the capacity of the capacitor between two parallel plates. Capacitor, plate capacitor. Parallel plate capacitor, that means we have to take these two parallel capacitor. Here is the plus Q charge, okay? Residing plus Q charge, here minus Q charge in the plate B, okay? This is distance shifted with some finite distance, okay? Here is the electric field. Line of the electric field, that means positive to this one, electric field, okay? Here, suppose we are observing from this side, then direction of the electric field lines positive to negative. That's why that from this charge plus Q charge going left to right, okay? And in this plate, that means here also going this side, right? This one, because in the negative charge, that means the electric field lines always invert to the negative point charge, okay? That's why direction of the electric field lines will be this side. Here our electric field due to plus Q charge plate, okay? Charge plate, then our electric field is equal to, in the plate we have already learned in Gauss's theorem, okay? Divided by 2 epsilon naught, right? And electric field due to minus Q charge plate, field due to minus Q plate, then E is equal to sigma charge density to epsilon naught. That means total electric field lines, okay? Total electric field lines. Here is net electric field lines, that means due to this charge electric field lines going this side, due to this charge this one also going this side. That's why it's net electric field lines. Net field E is equal to E1 plus E2. Suppose this is E1, E2, this is E1, then this will be E2, right? Then E1 is equal to sigma divided by 2 epsilon naught plus sigma divided by 2 epsilon naught. We have to solve this one, then final result coming sigma by this will be cancelled out. That means our E is equal to net electric field in this plate, that is this one. E is equal to sigma divided by epsilon naught, right? Then here is distance between this plate, this one. We have already learned in relationship between the electric field and potential, right? Our potential is equal to electric field into displacement, right? This one. Then electric field we have to already know this one, find out from here. That means potential is equal to our E sigma by epsilon naught into D. Okay. Here is the sigma just showing the charge density. Charge density in the plate we have to already learn charge per unit area. Okay. A is the area of the plate. A is the area. Okay. This is the distance. We have to put in place of sigma is equal to this one. V is equal to Q divided by A epsilon naught into D. Q, capacitance of this capacitor. This is the capacitor, right? Since our capacitance is equal to Q by V, that means we have to put the value of V is equal to this one in this equation. Then our capacitance is equal to our Q is there, right? Divided by our this one into D. Yes, into D divided by O. Q D divided by A epsilon naught. Then Q is going to cancel out. That means our C is equal to this A epsilon naught is going to there this one. C is equal to capacitance C is equal to A epsilon naught divided by D. We are giving the relationship between the capacitance area, epsilon that is the permittivity of the medium, D is the distance. That means this capacitance depend on this quantity, that area, and what is the nature, what is the medium, how much distance, this is depend. That means suppose we have to increase this distance, then capacitance will be decreased. We have to increase the distance, right? Increase the distance, then capacity will be decreased. Giving the relationship between capacitance and D is inversely, right? Similarly, other things here, area we have to increase, then capacity of the capacitor also will be increased, right? This one. This is the most important formula for you. Okay. And write C is directly proportional to this one. C is inversely proportional to D. Okay. I hope you have to understood this one. Okay. You would be problem, then you have to write in comment box. I will reply you. Okay.